Let's take a look at question number 31 from chapter 8. So the question says a simple random sample of 400 individuals provide 100 yes responses. We have three parts to this question. First, what is the point estimate of the proportion of the population that would provide yes responses? Then we need to find the estimate of the standard error of the proportion. And then our final piece, we need a 95% confidence interval. So this first part, the point estimate of the proportion. We have our sample size of 400, and we have what we're going to call X of 100. That's our number of yes responses. So our point estimate of the proportion, P bar, equals X over N. So we plug in the numbers that we have, 100 divided by 400, meaning that our P bar, our point estimate of the proportion of the population, is 0.25. So we will use that P bar now when we are finding our standard error. So our standard error formula looks like this. Now, if we had a population size, we could then test to find out if we needed our finite correction factor. But here they don't give us a population size, so we can just leave the finite correction factor off of our formula. So now, the only pieces that we need for this formula are P bar and N, which we have over on the left side of our screen right now. So we start plugging those numbers in, get 0.25 times 1 minus 0.25 all over 400, and we take the square root of that. So the numerator simplifies down into 0.1875 when you do all of that math. So the estimate of our standard error of the proportion ends up as 0.0217. So now we can use that piece when we make this confidence interval. So our confidence interval, our formula looks like this. We have P bar plus and minus the z-score of alpha divided by 2 multiplied by our standard error. So we have our P bar. We know that P bar is 0.25. The z-score of alpha over 2. Well, our alpha in this case is 0.05. We found that by taking 1 minus our confidence level of 95%. So our alpha is 0.05, but we need alpha divided by 2. So alpha divided by 2 is 0.025. So we have that, and then we have our standard error and all of the pieces needed to calculate it that we did in the last slide. So if we start filling in our confidence interval formula, it'll start looking like this. 0.25 plus and minus the z-score of 0.025 times our standard error. That z-score, we're going to be looking up 0.025 in the table, in our z-score table. We're looking for 0.025 within all of the areas. And we find that the z-score that corresponds with that is 1.96. So if we take 1.96 times our standard error of 0.0217, we find that our margin of error is 0.0424. So to provide this confidence interval, we take our 0.25 plus and minus our margin of error of 0.0424, and we find that our confidence interval comes out as 0.2076 to 0.2924.